Hi Internet. Hi Twitch. Hi YouTube. I hope I didn't forget anything. I always think I might have forgotten something. But here we are. Ready to do some more coding. I mean, I have forgotten to solve day 12 and day 18 part 2. Like for both, but I didn't really forget. I'll do that later. Is it a coincidence that those two are next to each other? It can't be, right? So it's a conspiracy. Anyway, I'm very curious about day 20. Rux mentioned that day 20 might be rough. And I'm very curious about that. I have not even fully read the thing yet. I've just like quickly skimmed through the text at the end of the last stream.
Ahoy!
Ahoy! Hi Korenchkin! Welcome, welcome. Nice to see you. There. Ouch! Hi Fierce! Nice seeing you. Also, ouch! What the heck? Hi Shrugs! I was just talking about you. Welcome, welcome everyone. How are you? I hope you're well. Congrats on being first, second and third. Hope you're all doing well. Hope you're all ready for the weekend. Also, let's start with some shoutouts. Shoutout for the one and only, here's Axolotl. How is Turnip Boy Robs the Bank? I have not played Turnip Boy Commits Tax Evasion yet, but it is one of those games. One of those games that is on the fabled list. Oh yeah, am I ready? Wait, what did I say? What did you react to? What, are you ready for day 20? Hi, ready for the weekend. Of course, of course. I already forgot what I asked. Me remembering what I said 30 seconds ago? Nah. You'll be playing it on Monday. I'm excited. I really enjoyed Turnip Boy Commits Tax Evasion, the perfect level of cozy and chaotic. Oh yes. It looks really good, and I think I would really enjoy it too. That means I kinda can't watch that much, but I will try to join and at least say hi on Monday. We'll see how it works out, but I don't want to spoil myself too much on that game. I think story might be essential there. Hi Flecky! Hello, hello. Wanna come on my lap or Meow? Yes. Feel free to. Yes? Alright, here we go. I think, yeah. Hello. Hello, hello. Head content. On a more positive note, made it through 4B and 5B. Whoa, okay, that is big and quick progress now. GG on that. Chapter 6 is awesome. I really enjoyed Chapter 6 in all its variants, I think. Hi CC, ahoy. Nice to see you. Wait, what? Oh. Ahoy! Ahoy! Ahoy, honk. What's the difference, really? Okay, we got exciting coding music here. It's the Chrono Cross soundtrack, as you can see. Anyway, I've never played Chrono Cross. I've played Chrono Trigger, but boop. Whose snoot did Korenchkin boop? It's gonna be a mystery. I got cat, and she's drooling. Drooling all over me. But yeah, I also wanted to give a shout out to Shrugs. We'll do that in a second. Shrugs is kind of responsible for all of this. I wasn't sure if streaming coding would be my thing, and then Shrugs mentioned this coding calendar and had it like day 1 on my own and realized, okay, I was able to do this, and Didn't take too long, so maybe I could try streaming it, and well, here we are. Now it's all I do. Little drooly kitty. Still a lot to do. Oh yeah, I didn't really react to that. Hope you get it done quickly. Like, do you have a lot to do on the weekend as well, or like still before you sleep today, but then it's done and then you can at least relax on Saturday and Sunday? I think that would be better, right? Probably. Still annoying to have a lot to do before you can feel ready for the weekend. There. Now the mic is also facing in my face direction. I didn't run the ads yet. I'm going to do that real quick, and after that we're going to be so ready for the coding. Oop. Coding music is more cozy again. We just got hyped up for the stream. Ay. That sounds rough. But am I misremembering, or did you recently say that you're gonna be like gonna be done with most of the stressful stuff for a while soon? I think you mentioned something like that, right? Should also go to space soon, not very productive anymore. Yeah, that's fair. Most of it, yeah, nice, okay. I hope not the one thing, though. What might that be? Oh well. But still, it's good that you get some things out of the way. Okay, now Flecky is licking my hand. That's kind of you. Yeah, I mean, I get it. I also always have too many things on my plate, and it's like, it would be enough to fill the next 3 weeks if I were like, okay, I'm gonna get all of this done now, but yeah, it will get better, just not right now. Yeah. I mean, as long as you know, or like are fairly sure that it is eventually gonna get better, that's something at least. That's something. And yeah, I think probably same for me. At least I have enough reason to be optimistic and think that it's gonna get better eventually. And it's also not that bad. I don't want to complain. I mean, some things are rough, but overall it's going all right. So let's see, what is day 20 about? It's about pulse propagation. With your help, the elves managed to find the right parts and fix all of the machines. Now they just need to send the command to boot up the machines and get the sand flowing again. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather to communication modules attached to the machines that perform various initialization tasks and also act as communication relays. Modules communicate using pulses. Each pulse is a high pulse or a low pulse. Okay, binary. When a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. That sounds very much like routing on the internet, pretty much, right? Like, kinda how it works. Just gets sent everywhere and then the destinations check, is this meant for me? No? Yes? Or is it meant for one of my own destination modules? Anyway, there are several different types of modules. Flip-flop modules, prefix, percent sign, are either on or off. They are initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. conjunction modules, prefix ampersand, is that the word? I think so, right? Remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input. Then, if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. There's a single broadcast module named Broadcaster. When it receives a pulse, it sends the same pulse to all of its destination modules. Here at Desert Machine headquarters, there is a module with a single button on it called aptly the button module. When you push the button, a single low pulse is sent directly to the Broadcaster module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing pulses. Don't spam click the login button if you're not logged in yet. I guess the login button is not that bad, but whatever. Pulses are always processed in the order they are sent. So if a pulse is sent to modules A, B, and C, then module A processes its pulse and sends more pulses. The pulses sent to module B and C would have to be handled, and then module A processes it twice and sends the pulses sent to module B and C would have to be handled first. The module configuration, your puzzle input, lists each module. The name of the module is preceded by a symbol identifying its type, if any. The name is then followed by an arrow and a list of its destination modules. For example, Broadcaster sends to A, B, and C. A, B, and C are flip-flop modules. A sends to B, B sends to C, and C sends to inf. And inf is, what was it called? A conjunction module, and sends to A. Alright. In this module configuration, the Broadcaster has 3 destination modules named A, B, and C. Each of these modules is a flip-flop module as indicated by the % prefix. A outputs to B, which outputs to C, which outputs to another module named inf. Inf is a conjunction module as indicated by the ampersand prefix, which, because it has only one input, acts like an inverter. It sends the opposite of the pulse type it receives. It outputs to A. By pushing the low button once, the following pulses are sent. Button low, Broadcaster. Broadcaster receives low and sends low to A, B, and C. A then sends high to B and high to C, and B sends high to C, and C sends high to the inverter. The inverter then sends low to A sends low to B, B sends low to C. C sends low to the inverter, and the inverter sends high to A. Hi Joe! Sorry, I'm reading this very long explanation here. I was already hit once, but this time I was safe enough. How are you, Joe? Welcome, welcome. Did you already get to start into your weekend? Is the work done for the week? I hope so. It's nice to see you. Welcome in. After this sequence, the flip-flop modules all end up off, so pushing the button again repeats the same sequence. Here's a more interesting example. Broadcaster A. A to inf and con, inf to B, B to con, and con to output. This module configuration includes the Broadcaster, 2 flip-flops named A and B, a single input conjunction module inf, a multi-input conjunction module con, and an untyped module named output for testing purposes. The multi-input conjunction module con watches the 2 flip-flop modules and, if they are both on, sends a low pulse to the output module. Here's what happens if you push the button once. Button low to the Broadcaster, Broadcaster low to A. A sends then high to the inverter and also high to the con module. The inverter sends, because it received a high, a low to B. And the conjunction module sends a high to the output because it only received one input, which was high. And how did conjunction modules work again? They were confusing. Remember the type of the most recent pulse received from each of their connected input modules. Initially default to remembering a low pulse for each input. When a pulse is received, updates the memory. If it remembers high pulses for all inputs, it sends a low pulse, otherwise high. And it did remember two different ones, low and high at that situation, so it did send another high pulse. Okay, makes sense. So the con sends a high to the output. B received the low from the inverter, so B sends a high to the con module. And then the con module has high on all its inputs, so it sends a low to the output. Both flip-flops turned on and a low pulse is sent to output. However, now that both flip-flops are on and con remembers a high pulse from each of its two inputs, pushing the button a second time does something different. Flip-flop A turns off. Now con remembers a low pulse from module A, and so it sends only a high pulse to output. Things are different, I understand that much. This is so much explanation. Push the button a third time. This time flip-flop A before B can turn off, the pulse sent to con is sent first, so it briefly remembers all high pulses for its inputs and sends a low pulse to the output. After flip-flop B turns off, which causes con to update its state and send a high pulse to output. Finally, with A on and B off, push the button a fourth time. This completes the cycle. A turns off, causing con to remember only low pulses and restoring all modules to their original states. To get the cables warmed up, the elves have pushed the button 1,000 times. How many pulses got sent as a result, including the pulses sent by the button itself? In the first example, the same thing happens every time the button is pushed. 8 low pulses and 4 high pulses are sent. So after pushing the button 1,000 times, 8,000 low pulses and 4,000 high pulses are sent. Multiplying these together gives 32 million? 32 million, yes. In the second example, after pushing the button 1,000 times, 4,250 low pulses and 2,750 high pulses are sent. Multiplying these together gives 11,687,500. Consult your module configuration. Determine the number of low pulses and high pulses that would be sent after pushing the button 1,000 times, waiting for all pulses to be fully handled after each push of the button. What do you get if you multiply the total number of low pulses sent by the total number of high pulses sent? Okay. I kinda understand. Interesting. Was doing some modded Minecraft with my friend. Crimes were committed, progress was made. I love it. Both of those things. we do like, well, not all crimes, but I'm sure you committed all the cool crimes. And progress we also like. So nicely done. No routing as usually directed. Oh, it is. This is more like what happens on the Ethernet layer. Okay, yeah, maybe I confused things. It's been a while. Except that you usually have switches that remember which address is on which port. True. It was just the initial setup thing where things, yeah, when first something new enters the network, kinda. And it will not broadcast a message on all the other ports. Yes, that's true. Now I remember. That's the thing I was thinking of. This flooding of the network to find an address that is not known yet. There were some pretty cool crimes. Summoning boss mobs. Sounds good to me. The boss mob may have slightly modded all. Oh, well, that is not a great outcome. Well, it was just Minecraft pets, so I suppose it's okay. You shall get them back. Revive them. Necromancy. More crimes. Why not? Oh, I also saw that you were streaming again earlier on Discord. I think it was Baba, but I'm not entirely sure. I was scared to try and join because I was scared it would again not work if I tried to join from my phone. And I didn't want to be weirdly trying to join again and failing, so... Next time I'm on the PC, I'll join from there and then maybe simultaneously see if I can join from my phone. More Baba packs. Nice. How was it? I was confused basically the whole time. Damn, and I wasn't there. That's the best thing. Also, hi CC on YouTube. I completely forgot to update my my restream thing, and I just saw it on the YouTube window. Let me quickly actually change that so that I can see the YouTube messages on my restream chat window. Updating. It is done. All right. Now I can see stuff on my... yeah, now I should be able to see the YouTube messages as well. Okay, we're not gonna get our puzzle input yet. The test data is more than enough for now. So let's get this started. I'd say I'm scared. Like part 1 already seems kind of rough, but doable. I wonder what they have in store with part 2. Like this is a very, very long description for a part 1. We'll see what comes next. I'm already intimidated. But hopeful. Part 1 seems doable, I would argue. Like, if I don't miss something essential. Which I might, but we'll see. Second! Yes, now I can see the YouTube messages in my restream chat thingy. Perfect. If you're lucky, part 2 is just press the button 42 billion times how many pulses are sent. Yes. Actually, that would be probably doable, because then again, like they showed in the example, there is some repetition after a certain amount. So if you have the repetition, you can easily upscale it from there and you don't have to run it 42 billion times, right? So, yeah. Alrighty. First, our fake puzzle input. Let's get that over here. Let's start with the very simple one. Let's just get that working to start off. Is this what the ultimate puzzle input will look like as well in general? Yes. Okay. I would say so. Okay, cool. So first thing is like get the broadcaster out of this whole thing, because it's not going to be at the start. I mean, we could easily modify it so that it would be at the start, or just remove it completely and hard code it in, but no, we're going to read out the file, I think. So day 20. It's obviously pulse data. Let's see how far we got. Start with some good old console logging. I think I didn't save. I think I... See, that's why I'm console logging already. Input data day is the thing. Somehow got rid of the Y. There we go. All right. Good stuff. Now... Actually, we could just continue from here to map this. I'm just gonna call it pulse. It's not quite a pulse. The pulses happen in between. These are the nodes in our network, but yeah, it's okay. Maybe I should call it node. Let's be a bit more precise here with the naming. So we have a node and we want to do stuff with that node precisely. Start with this. Yeah, that worked so far. Okay, someone is setting off fireworks outside right now. Because why not? 2 AM on the 27th of January, the obvious day for fireworks and time and stuff. Oh well. People. Oh well. Hope they're having a good party at least. So, I kind of want to split these as well here. I'm just thinking about...
Bapanada.
Bapanada indeed. Oh, people. Yep. I could also imagine something like you need X low and Y high pulses. How many times do you need to press the button? That also seems still doable. We'll see, we'll see. I wonder what the most elegant way is to split all the right side thingies in my thingies. What if we... I could just do it in a non-elegant way. That's probably a good idea, maybe. Well, maybe I should. Rather give this the convoluted name. Could also just use 2 arrays to make things simpler. Or I just keep it like this, because it's gonna be pretty easy to just read it like this, I think. So I'm just gonna keep it like this for now. We can still split it apart later. Best frame of rock in the water or be not to be? I'm not sure I understand. The best frame of rock in the water or be or not to be? Anyway, hi, nice to see you. Yeah, I'm just gonna work with the data as it is, I think. That's it's good enough. I can work with this. So, first we're gonna identify... We don't even need to do this, right? Let me again look for array methods, cause can I look for some... What is this? Okay, this is completely something else. I was thinking if I could use something like you can do with if these were objects in there, which they aren't, then I could look for something like name. I could like find the thing where the name is broadcaster, but I don't think I can just do it like this, right? Yeah, well, we're just gonna do it like this then. Still want to do it more elegant than looping through the array. Officially, like when we're mapping, I think we're also looping through the array, but still trying to use more built-in methods. So that's the pulse data dot map. We get a node, and what we want to do with that node is we want to do something like this. Can we just write something like just trying if we can write something like this. Can write something like this, and the return thing should be what actually gets mapped into the new array then, right? Or broadcaster would be an array, but that's okay, probably. So not if true, but if node 0 equals broadcaster. Let's see if that works. Oh, and we get a lot of undefines for the others. That's that's not ideal. Huh. Does this work? Does this make it better? Null, null, null. I mean, problem kind of stays the same. Not a huge problem. Kinda. Because we probably have something nice here. Yeah, just the filter thing. Yeah, this is not very elegant and probably kind of inefficient, but whatever. Because now we're kind of looping twice through the array, which is, I mean, probably with the map and the filter, how else would it work? But that's okay. Could the filter have helped us before? Probably, right? What if we just used the filter and wrote something like this in there? Okay, I'm gonna try that. I I was thinking of filter first, I just couldn't quite figure out how it should look then, but this might be what we need. Because now we can just do node 0 equals 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 broadcaster, right? I think that should do it. Nope. Oh, because I'm... No, wait. Technically... don't quite understand what the issue is now. What am I missing here? That shouldn't be the double quotation marks, right? No, that gets fixed by Prettier. That would have been weird if that was the issue. It's literally right here. Yeah, and it isn't. I just maybe not. No, I did run all of this. Looks like it should work. I thought so, yeah. Clicking through all my windows, which is kind of unnecessary. If I knew where I wanted to click, just further over here. I'm gonna remove one equals and see if that changes anything. Maybe I'm too strict. Nope, that still doesn't work. Should it not be? No. Ah, I was gonna say, is it the braces? But apparently it is the braces. I was wondering. Okay. Good to know. That would have been actually my next question here. Interesting. So, yeah. Good to know. Well then. There we go. Beautiful. Okay. And then we just don't want it to be an unnecessary array in an array, so we do this, and there we go. We got our broadcaster. Cool. All right, that's our starting node pretty much, right? So... okay. Maybe this was unnecessary because we kind of need to keep track of the status of all of them anyway, right? But okay. So we'll have to loop through the whole data regardless, and we could have taken care of this later then, but yeah, whatever. Because all the starting is just like starting from button thing to broadcaster anyway, right? Whatever, it's fine. I learned something here, so that's the main goal anyway. So let's do the looping anyway. Yeah, because we need not only this information that we get from the puzzle input, but a third set of info, which is like the button state, or rather, we need multiple things. We need to know different things for the different types of nodes as well. So for the broadcast module, we don't need any extra information because it just always does the same thing. When it receives a pulse, it sends the same pulse to all of its destination modules. So all we need is to know its name and the destinations. Then, well, the button module, that's kind of just the starting thing, which is also trivial. But yeah, the flip-flops are either on or off, so we need to keep track of, is it on or off right now? And we need to keep track of do we need to keep track of anything else? Not really, because yeah, we just need the on and off state. Okay, but for the conjunction modules, we need to keep track of how many inputs it has and what it last received on those inputs. I mean, that's one array basically. One array of length x, and x is the number of inputs, and they all get set to low at the start, or 0 for example. And okay. Okay, cool. So we know what we want to have information-wise at the end. We might have to loop even twice, because first we need to figure out how many inputs each, or even 3 times, I don't even know. But yeah, we need to figure out which nodes are conjunction modules, and before we know that, it's gonna be a bit difficult to gather the inputs towards them, right? Maybe. I mean, we could just proactively collect them, and then if they are conjunction modules, just put in the information, and if not, just throw it away. But there might be better ways to do that. So anyway, because here, when we go through this from the top to the bottom, we would here see, okay, this goes to inf, but we wouldn't even know it's inf. Just like a final module, like the output in the other thing, or is it a conjunction module, or is it a flip-flop, or what is it? So only then we know what information we need for the inf module once we are here. So yeah. Okay. They are initially off. Okay, so that's okay. We can work with this. So, if that should be the first character of the string, right? So this should always give us the information of what kind of module it is. I think that works. Okay. Maybe I should look at the actual puzzle input, but yeah, that looks reasonable. We will once find a B, that's our broadcaster. And otherwise we find information on what kind of module we have in front of us. So, so yeah, we actually really don't need this. I think. Yeah, but whatever. I'm just gonna do it all the same. That makes more sense. So, do I even want to do this like this? I'm not sure if I want to have a separate broadcaster thingy. Oh, rather maybe this. I get what I wanted to get here, like this. Like I wanted these ABC to be mapped onto different subarrays before. It isn't really necessary, but I wonder if I could do it. I think I could do it, right? If I did this. But it's not necessary. So can actually just push the whole node 0 here. Okay. Or the whole node. Yeah. That should be the broadcaster ABC. But it might be nice to have the broadcaster and the ABC in different nodes, right? Am I not doing that yet? I'm not doing that yet. I think. Yeah, no, they are different things, so no, it's fine. It's just that I want to add a third thing, but yeah, that's also doable. Okay, so if it's the broadcaster, we don't need any extra information, so we just push what we have. Unless we do want to turn it into an object. Would probably make sense to turn it into an object, right? Because then we can much easier find the thing that is called broadcaster or called A or called B or whatever. Yeah, okay, let's do that. I've rarely worked with objects while doing these, but I think I know how to do it, so let's see. Is this correct so far? I hope it is correct so far. This seems to be correct. It's accepting it at least, so that's good. Okay, I think we can do this. Sorry for struggling so much with the most basic things, but we're getting there. Eventually I'm gonna get good at these basic things. It's just gonna take me a long, long time. Okay, so now we go for the more interesting ones. So if we have this, we also push something to our node data. And specifically we push maybe we also want to have a type in here. We're just going to call
the Tariff
this.
Act of 1789 established to protect domestic manufacture, was the second statute ever enacted by the United States government.
Base time, I see.
Explosion Day, gorgeous.
It was indeed Explosion Day, 20 minutes ago.
Space.
Space. Alright, thanks for hanging out, Korenchkin. Thanks for spending some time here. Thanks for helping me out with that explicit return. I was just wondering, could it be my braces? I ultimately noticed that was the difference between the example and what I had here. But yeah, thanks for hanging out. Good luck with all the stuff that you have to still get done. I really hope that you're gonna get all of it done tomorrow and can at least chill on Sunday. It's different in Rust. Okay, I have to learn more languages, but maybe first really getting good at one is a good goal for now. I'm optimistic that I've slowly figured out the foundation for this one, and we're getting somewhere now. Working with these objects seems reasonable, probably. Yeah, I think so. Actually, we might not want to take the first character if we go by name, right? Because we won't know the name from, like, the full name from the destination otherwise, so... Splice? I think it's Splice, right? Oh, that's array. Then it's slice. That's also array. Okay, we also have slice and only slice here. Okay, but slice should do the trick. Okay, so just slice 1. And with these, we also need state. And state is just true or false, I suppose. Why not? And we start on false. Okay. And then the last else if. Okay, why are you listing? Okay, because I have one more thing in there. But that's kind of ugly. Lydia, this is kind of ugly. Oh well. Whoops. I think I caps locked myself. Yep. Okay, here we go. There we go. And state in this case is an array actually. Okay, and that should be the first cycle through my array, I think. No date. Why did I say no there? Okay. Alright, we have Roadcaster now because I cut the first thing off. Yeah, that was stupid to do for this one. But that's okay. Everything else looks good actually. I don't know why I set false in here because that's not necessary. But otherwise it looks good, I would say. What? Why is it? What did I do? Note 0 slice. No. Okay. Okay, okay. There! Finally. Okay. We have our destinations. You know, we really could easily make this into an array. At least this one I'm fairly certain works. Yes, perfect. Okay, wonderful. I like that much more. We can do that for all of them, by the way. Nice, I like it. Now we just have to, while we're doing this, also remember the ones that are the ones that are of type what conjunction thingies, you know, the ampersand ones, because for those we need to collect the amount of inputs that they have. Unless we just want to remember that for all of them. That would be possible technically, maybe useful later for something. Nothing goes into the broadcaster, right? So, yeah, but we don't start at the broadcaster in the actual input data, so that's not that helpful. Maybe we just keep track of them in a separate thingy here and then go for a second round. That should be okay, I think. So... Conjunction, okay. Then let's call it conjunction data. Always write date. Conjunction data. Okay. I mean, this will give us a list of the names of them. Yeah, might be good enough for the second round. Or would we rather go through... Yeah, we're going through our node data now, that makes sense. I think we want to go through all the destinations, right? So rather... Yes, so if it's in the conjunction data, we now want to find this thing in our node data, right? I have to actually... Array find, that's what I was thinking of earlier. Ah, perfect. That's exactly it. Okay. Somehow I didn't see that earlier. That's okay. That might have helped with the broadcaster at the start. Anyway, we don't want to find the element that's larger than 10. We want to find the element that has element name equals dest. And we want to for the state. And we want to push because now it... Yeah, we want to know they all start in the same state, right? They all start in low state, I think. Or remember low pulse. Let's just say low is false and high is true. Let's keep it simple. Okay, although, is this enough? Kinda need to know which source it came from, right? Damn, that's annoying. Okay, well, let's make it another object. Why not? And the name is the node name that we're working with right now. Okay, that seems okay then. I think this... Is this it? I think this might be it. That didn't change anything. Should have added... Oh, I didn't console log it a second time. It has an object in there. That makes sense. This is an object. Okay. Seems fair. How many elements? It's just 1, 2, 3, 4, 5. Okay. Just want to have a closer look, just to be really sure that the right stuff is in there. I did not lock the right one. Why is this 4? Shouldn't this be 3? 0, 1, 2, 3? I'm confused. Ah, no, of course not. Yeah, that's the... So I'm stupid. This is the input that is locked in here. Yeah, okay, that makes a lot of sense. This is what goes into the inverter. Yes. Okay, cool. So now we should have all the relevant information in our node data, I believe. And now we can work with it. I like it. Now the hard part begins, in a way, with keeping track of what happens when, etc., etc., etc. And yeah, like doing things in the right order, which is okay, I think. We can use basically an array to keep track of what needs to be done when. And just, yeah, work through the array from top to bottom and always pick things from the top to work with. Yeah, I think that's a good idea. So maybe we need a function here. Okay. So if we activate the node, we want to have a node element that looks like one of these wonderful elements, one of our node thingies, and we do want to know what our broadcaster is, because the broadcaster is basically what we need to activate first, right? So we just can push our but we don't get a nice broadcaster module like this, so we could just have create this already, the node stack already earlier, and then just whenever we find the broadcaster, just push it on there. That's a good approach, I think. Node stack is there from the start, and here if we find the broadcaster, we also push the broadcaster onto our node stack. Just gonna copy this. I could also figure out how to access the last element I put on the array, but copy paste does the trick. Unless you want to specifically reference this for some reason, but I don't think that's necessary. So yeah, let's just create a new object for our node stack. Okay, so now we activate the node, which means we first have to figure out like what type it is. Oh yeah, this is fine. Yeah. So if we have three options, the type can be B, the type can be % or ampersand. The type is B, then all we need to do basically is for each of the destination elements. I mean, that's part of it. We also need to send pulses and remember which pulses we send, right? So we also need to know which pulse went in, but we always know that does the broadcaster always do the same thing? It does, right? The broadcaster always starts with a low input, I think. Single low pulse to the broadcaster, and the broadcaster sends the same pulse to our destination modules. Okay, good. So that's a start. So basically we also want to keep track of shouldn't I have done this? Yes, I should have. Okay. So First we update our low pulses. Plus equal. Node destinations. Node dot destinations dot length. Right, that should do the trick. +1 because it's the destinations plus the one input it got. Yes, I know some of those words. I'm struggling. I only kinda know these words myself. Hi Opal, nice seeing you. Okay, so how are you? How are you? I hope you're well. So we do that first. We update the amount of low pulses to the destinations of this +1 because the initial button press also did one low pulse. Then for the destination, do we even need this? I think we don't need the node in here because we kind of get the node from the stack anyway. I think. Maybe not. I don't know. We'll just work with this for now. And we push our node data. Yep, that seems correct. That's the elements that we need to push. Okay. Seems good. But that's not all we need to do. We also, like on our node stack, we don't only need the node, we need the node and the pulse that it receives, right? That's probably better. Also, I hope that this doesn't copy the element, but just references it. Not entirely sure if that's the case, but we'll see if that's the case. I'm good, overthinking myself into stress, but don't really have anything to worry about. Just my birthday party tonight, and people are going to expect a speech, and my family is meeting my happy birthday, by the way. Is it your birthday today, or just your birthday party tonight? In any case, happy birthday. Shall I sing? I shall sing, right? Happy birthday to you. Happy birthday. Oh, next Wednesday? Doesn't matter. Happy birthday to you. Happy birthday to you. Happy birthday, dear Opal. Happy birthday to you. Whee! And my family is meeting my fiance for the first time, and I've left the party open-ended, so I'm going to make decisions. Going to have to make decisions. Yeah. But I'm sure it's gonna go okay, right? I mean, it's a birthday party. It's people who like you there, so I would hope that it goes well. Really hope it does. But yeah, as you said, if you say that you don't really have anything to worry about, that's a good thing. Yeah. Okay, so yeah, I realized that we need to push more onto our node stack. I mean, at the same time, we could just make a pulse stack, right? Because unless I'm not sure. We might not actually have to update put that on a stack. We could just update it right away on the element itself, right? Like here we have that element. So we could just update it right at then and there on this element. Really hope this is not creating a copy, because that would suck. Then I would have to update it in the node data thing as well. I hope it's just a reference. I'm not sure though. I think it's creating a copy, right? I mean, documentation would tell me. Returns the element. Doesn't say it creates a copy of the element. But if I mean, yeah. This is just a number, so with a number it certainly would create a copy of the number. Don't know if it behaves the same with objects though. Oh, we're gonna find out. Otherwise, we'll just have to keep working with this here. That's also okay. I mean, basically it's okay though if we just push onto the node stack. What do we have on the node stack right now? We did push the whole thing on there, right? But we kind of don't need, we just need the name, really. So probably we should just, on our node stack, just have the name. That should be enough. Because then we can easily find that in the array. Okay, we're gonna work with that. Just push the name. Then we also... Yeah, we still need to find it to update the thingy, but we don't need to find it to put it on the node stack because we know from the destinations already. So we just push the dest. That works. And now... just gonna do it without anything like this. If node data find element, etc., etc. So if this type equals the easy thing is I have to read again how these behave. Flip-flop, on or off, initially off, receives a high pulse, it is ignored and nothing happens. If it receives a low pulse, it flips on and off. Okay, there we go. So that is indeed what's gonna happen here. So if the type equals, no, the percent, right? That's the flip-flop thingy. Then on that same element, we want to access the What's it called? The state, yes. The state, and set it to the state that it was not before. Oop. All right. That should technically work. Okay. So I'm just gonna do it once, but eventually we want a while loop, which is while node stack greater than 0. We activate nodes. Now the thing is to push and pop always puts it on the top and takes it from the top, right? So since we're pushing, we don't want to pop afterwards, but we want to unshift. Is that the right thing? Let me see again. Yes, the last element, but we want the first element. So it's either shift or unshift. Removes the first element of an array. Perfect. Okay, so we want to shift then to make sure we do things in order. What was it now? Shift, yeah. Shift. And then we, do activate node of I'm wondering if it would be smarter to also just work with the node name here. Probably right. Because we can just get it here. Oop. John Pantone or John Pant 1. Hi and hello, nice to see you. Hi, welcome. And hi Nineberry. Objects are always reference types in JavaScript. Okay, that's good to know. Also hi Luna, welcome. Thanks for the Lost Travolta. Grüße nach Leipzig. Grüße zurück. Don't know to where, but danke. Und Österreich. Ah, okay, cool. Dann liebe Grüße nach Österreich. Yeah, we are doing some AdventOfCode here. And I'm struggling because I'm new to all this still, even after 20 days of coding. But we're managing. It's just always a bit of a struggle, just getting to know all these different functions and using them as we go. But thanks, Nineberry. Thanks for letting me know about the reference type thingy. That is good to know. Kind of, I think, working around the possibility that it's not already, and I don't think I want to shift from that right now, but it's fine. So at least it's good to know that we don't have to worry too much about that then, if I understand correctly. So activate node, next node name, that is probably good enough, but then first we need to say exactly. We have to get the node by the node name, and then we don't have to worry about much here, which is nice. Rather const node equals node data dot find, etc., etc., etc. All right, there we go. Let's just remove that real quick because I don't want to run this forever right now. I don't want to write more code. I want to see what happens just with this right now. Just move it. Thank you. Also, how are you, Nineberry? Welcome in. These were all in state false, and now they're all in state true. That works for me, I think. Because we always change the next things in advance, so then they will know what to do next, right? So in this example, because of the first low pulse entering, let's evaluate. I just close things over here, which is not smart. Or not closed, just minimized, but still. This is where I wanted to go. I think. Where was I? Oh yeah, I wanted to go through the example. So basically, in this simple example, of course, we have these 4. We have counted those 4. We sent them all to A, B, C, and then A, B, and C are on high mode. That is exactly what we've done. We set them from false to true, which is perfect. So, which means they are sending a high pulse to B, C. I mean, yeah, actually, no, that's correct. A is sending a high pulse to B, which doesn't change anything about B. B is sending a high pulse to C, which doesn't change anything about C. C is sending a high pulse to inf. Yeah, that makes sense. Okay, cool. Okay. I think this is good so far. Nice. So now we take care of the next ones. Percent. If node dot state equals false. So if it's in low mode, let me see again. It will just either off or on, initially off, if it shifts it on off, was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. With a high pulse it's ignored and nothing happens, so it will just not forward anything at all then. Okay, that's important. Maybe we need to know more then. We need to know if it flipped recently, probably. Because... yeah, we need to know what state it was in before. Just having this, like, we need to know at least... yeah, we need to know if it's on or off. But also when we access it, we need to know if it was just switched to that state or if it has already been in that state before. Like if it received a high pulse or a low pulse before, basically. Like if it received a low pulse, we know it was flipped, so then we can just read everything from that. But we need two things, like did it receive a low pulse and what's its current state? That's, yeah. Okay, so we need more information, probably. Yeah, because the previous state is important for figuring out what kind of pulse it's gonna send. Okay. All right. Dangerous. Hi Mima, welcome in. Thanks for the thinking hardly and for the Kevin. How are you? Hope things are going well. Hope you're ready to start into the weekend and hyped and all the things. How do we ideally do this? We have to have more information. I mean, this is, yeah, as I said, it's just these 2 bits of information. We need to know what state it is in now, and if it just received a low pulse, which would mean that it's switched. So we're gonna keep the state as what it is in right now. And I guess low received false. Or gonna keep it shorter, low R, false. Okay, yeah, that seems to work. So, so since it's a reference, we can just make this much nicer. Replace all this long nonsense. Whoops. Yeah. That's what I thought. There. Right? No, still something wrong. There. Still no? Still something wrong? Oh, okay. I just didn't write this. That should be enough, right? So this will be true or false as well. First updates its memory, makes sense. If it remembers, that's the conjunction. No, first this. So flips between on and off. If it was off, it turns on and sends a high pulse. So yeah, basically if it is on, it will send a high pulse. If it is off, it will send a low pulse. Okay. We'll see what that exactly means. But for now, we know that this is what happens. Okay. But yeah, we wanted to do more here, right? Because now we're only updating the state, we're not updating test node dot low r equals true. There we go. Actually, yeah, could have also just written. Yeah, let's keep it like this. This is, we know it since it's the broadcaster one that they won't be, because they will remember from the previous button press. Okay, so this is actually necessary, yeah. But low received is definitely true. Okay, after the broadcast module. Okay, and we'll think about this here later. We can try once more. Why is low R false? Didn't I say low R should be true? That I don't understand now. The state gets updated, but the low R doesn't for some reason. Oh, I didn't save. Is that just it? Yeah, that's just it. Okay. Always remember to save. God damn it. Sorry, I ruined lines 20 to 27 with Kevin, just decompressing from the day. Chicken on the oven, Carly Ray Jepson on my ears. What's the chicken doing on the oven? Is it chilling? Is it sleeping? Poor chicken. But yeah, decompressing from the day sounds good. Okay. So we have the relevant information now after this first thing, and we know what we want to do next. Okay, so we want to do here a high pulse if our node type is this, and that means, well, it means the same as before pretty much, right? So basically we still have to also add that here first before we write anything down there. I mean, not necessarily before that, but still. So let's write that part. If dest node dot type equals ampersand, then we need to find the state. Exactly, the state that has the right name, and set it to true. should be good. We find that and not equals and set it to true, right? Because it received a low pulse. Is that correct or is it not correct? It might not be correct. No, I think it is correct. Let me see. Remember the type of the most recent pulse received from each of their connected input modules. Initially, remember to be okay, but it will still remember a low pulse then. Okay, so it doesn't get set to true, it just stays the same. So basically, we do nothing in that scenario, so we can just, again, ignore this, but this will be probably useful code later. So I'm just gonna move it down here. It might be useful. If it was a high pulse, that's exactly what we're checking here, then we definitely have to do this. Set it to true. Makes sense. Okay. That's a good start for that. Let's keep it there. So then this is done because we don't change anything if the node type is the ampersand. The state stays the same because it's receiving a low pulse and it defaults to low, so alright. Still this if actually have to, of course, first get a dest node here. Yeah, okay. I think that makes... Okay, we have a problem somewhere. Dispersion expected. Okay, yeah, that makes sense. Yeah, okay. We don't have the dest node yet. That's a huge issue there. So again, something wrong. Why are you not happy? Oh, it is happy now. Okay, good. Wait, it is not happy. Come on, make up your mind. Prettier is not happy, so I must have messed up the bracket somewhere. I assume. Shouldn't that cause problems? I'm confused. We don't have any problems in the workspace, but Prettier is not happy. How so? Did I... I'm very confused about that. When was Prettier still happy? I might want to just keep this, but then... Nope, still not happy. Why are you no happy? Is this still valid, what it says here? Maybe it is. Oh, no, Prettier is happy? No, it isn't. Okay. I'm so confused about everything here. Before the high pulse, so something is wrong with this. I see. Okay. That's what's wrong, right? Nope, there's something else wrong. Apparently that was fine. Because I call it node, I think that's not good at this point. Maybe? Nah, still not happy. There's something wrong with it, apparently. Okay, I was gonna say this would be node name then. Still not happy though. But that makes sense to go node name. I kind of was just confused there. Why is it not happy with that? I don't understand. Wait. Yeah, no, that should be... I think I see. Maybe? Yes! Okay, finally. Signing true to the result of find makes no sense. Yeah, no, I understand that. Yes, I see where I went wrong. I just saw it in the same moment you wrote that. Alright. There we go, finally. Okay. Now, what did we want to do with this? Right now we say that we are in high mode, right? So we're also sending a high pulse. Yes, okay. High pulse gets sent if the destination is... These are just ignoring high pulses, right? So... Am I confused, or is that the case? Initially off. Low pulse flips it off, high pulse is ignored and nothing happens. Okay. Conjunction. Okay, I did not do the conjunction right. What did I do right now? This should be the conjunction. I mean, yeah, no, I did. If the conjunction receives a high pulse, it sets the thing to a high pulse. That makes sense. Okay, good. If this receives a high pulse, nothing happens, so this can go away. This can go to down here maybe, because here something does happen. Okay, so far everything is fine. I think this is pretty much identical. Whoops. Did too much there, but of course we set it to pulse. Then it remembers that the last thing it received was a low pulse. Okay. Makes sense. And for these, again, let me see what... okay, so this is a problem because, yeah, of the order of operations. Okay, I didn't quite consider that it might receive like multiple overlapping inputs right now. That is problematic because then once we get to actually utilizing it, I've already changed the state into what it will be in the final thing if I keep doing it like this. So I think I need to do it somewhat differently actually. Might not be enough to just keep track of the node name, but yeah, we rather have to do it somewhat differently. We have to keep track of the node name and what pulses it receives and not immediately adjust the things according to the pulses. Okay, fair enough. Okay. So suppose the destination type doesn't really matter then at all, because it's gonna figure it out on its own what happens. Maybe that's more practical anyway. Then we also don't need to find the destination node really, for now. Yeah, like the type of it and everything. Okay, but it also, so yeah, okay, so we need more. Activate node. It also wants to have the source then, and that are the three things we're gonna save on the stack. Like the name of the node that is supposed to get activated, the kind of pulse it will be receiving at that point, and the source it receives the pulse from. And hopefully that's enough then. So somehow we've got to put all of that on there. Might just be an object as well if we just put it all on there anyway. I'm gonna keep it in here like this for now, but okay, it keeps going. So we don't need to find it, we don't need to adjust stuff in the percent ones, but all we need to do is do the pushing part that I've commented out somewhere and push the right information. Yeah. Node stack dot push. Okay, what we want is something with a name, something with the pulse, and something with the source. Pulse because it's a low pulse, and source is my node name. Well, that's simple enough then. I mean, that's all that happens when we activate the broadcaster node. Doesn't do anything else. Okay. What was it? What did I call it? Pulse. Okay. Doesn't really matter. Okay. Okay. That should help us find the element. Okay. So that's all we need for our broadcaster node. So now again, so now we don't need this if low received. We don't even need this whole low received attribute, I think, anymore. So I was right the first time. Okay. Okay, there we go. No, that's not here. That's the start. God damn it. Losing track of everything here. Don't even know where this closes. Down here, right? It's like the whole thing. Okay. Whew, okay. Almost feel like just rewriting it all real quick, but I don't know if that's smart. So, okay, we have our node. So, so yeah, now first we need to actually change our node state. There. So, and after that, oh, but only if it received the low pulse. Yeah, of course. So, right. So if node info dot pulse we want a low one, so all we need is this. Yeah, only under these circumstances we're doing anything. Fused. Oh, did I not remove the thing here? Is this fine right now? No, it's not fine right now. That's what I thought, okay. Alright, yeah, that makes sense. Good. Okay, yeah, and then, so first we check if it got switched, and then we check what it was switched to. So now if we're in high mode, we also push that information for all the destination nodes, right? Do we even need to differentiate? Because all we do is just push the information, right? We don't do all this other nonsense. So I think I think I might have just overcomplicated earlier because I was just, yeah, trying to do it all in one go from one step before it actually happens. So yeah, really just deleting it all and doing it again seems smart, right, Mr. Cat? Right. Okay. So we switch the node state if we receive the low pulse, and then and only then we're doing certain things, and well, particularly we are yeah, now it matters. For just counting, we need to keep counting, so if node state there we go. Makes sense, I think. So that's the first thing, the counting part. Second thing is pretty much the same as up there, right? What do we push? We push not false, but we push node.state, I think. Yeah, okay. If it was off and turns on, it sends a high pulse. If it was on, it turns off and it's a low pulse. That's what I've done, I believe. Okay, and we push all the destinations onto the node stack. Now for the last one. I think this is okay so far. I don't know if I can. Let's just. Is it for no, it's not for the destinations, it's for we also need to update it first. So that's important. There we go. Now that's important here. So yeah, we go to that one, and we want to have that once. Doop. State, exactly. And we want to set it to there. That's it, I think. Okay, makes sense. State. Whatever. Or is it? Yeah, it should be right, because the state has... That's kind of stupid, by the way, but whatever. Yeah, we push something to the state, an object that again has a state thing. Whatever. I'm just gonna hope that I'm not gonna get too confused by this, which I probably am. That's okay. Okay. Now we can check if equals to node dot that's like all the sources basically, and if they're all true, then we do something. Hi, Kevin. The struggle with this one. I don't know why I'm so confused and confusing myself and making it more convoluted than it has to be, but maybe that's just the way my brain works today. Kevin is stuck on the wrong height, you mean? Yeah. Okay, what do we do then? So, conjunction modules, remember the most recent pulse, initially default to low pulse for each input. When the pulse is received, conjunction module first after the summary for that input. Then, if it remembers high pulses for all inputs, it sends a low pulse. Thanks, Joe! Thank you! Also, was there supposed to be the cat purr on the hydrate? I don't think so. But there's a... Oh no, that was supposed to be only on the stretch. The stretch was supposed to do the purr, but you didn't redeem a stretch, so I set up something wrong. Gonna fix that real quick. Stretch is good. Water? No, it should... Doesn't show that it would do this. Ah, I see why. Okay, I see why. They're both set to trigger on the water redeem, like both actions. There we go. Stretchy water. Yeah. I'm gonna stretch anyway, because that's a good idea. I'm gonna drink this. This is mostly water. Not a lot of sugar though. But hey. Alright, I think we're getting somewhere. It's taking longer than it should, but we're getting somewhere. The struggle is real. So, we got that. And yeah, when When they remember high pulses on all inputs, it sends a low pulse, otherwise it sends a high pulse. Okay. So that means basically again this thing here. But if all are remembered to be high, it sends a high pulse, right? No, if all are high pulses, it sends a low pulse. Okay. Smarter thing to do is put this in here. I didn't copy it. That's great. God damn it. There. Alrighty. Okay. There we go. Okay. Is this it? Did I forget something? No harm in just running it real quick, right? Damn, node name is not defined. There. I guess it should be node.name or something. Yeah, I think it should be node dot or just node info would also do the trick, because that is what we're working with. Wait though, I'm no node info dot name if anything. Yeah. Okay. Yippee! It ran till the end. Let's rather lock the... I don't know if I didn't track all the high and low pulses, right? I forgot to count them for this here. Yeah, that's... Okay, took me a while, but I think it all kind of makes sense. Four and 8? I don't think that's quite correct, is it? I don't know, maybe it is. Yeah, that is correct. 4 and 8. Nice. All right. That's one button push. But then we need to do the next button push, right? So, we need to push the button 1,000 times. We could just do that right now, because for now it should be fine to just do that 1,000 times. I just wonder how I would do this preferably. Like, because I always need to empty the stack first before I press the next button, right? So, I mean, I could just do this and keep this like this, but then I would have to have something that always puts the right data back on it, which should be fine, because all that's on there is just these 3 things. So okay. Let's start with 1. Hi Legume, welcome, welcome. Nice to see you. Hi Raiders, hi everyone. Hi Tiki Peak, hi hi. Schön dich zu sehen. Ich switch dann gerade auch einfach mal zwischen Deutsch und Englisch hin und her. Danke fürs Reinkommen. Bin ich hier richtig bei Code Oscuro? Ja, bist du. Wie war Prince of Persia noch? Ich hoffe weiter sehr, sehr gut. Ich hoffe, du bist weiterhin halbwegs okay mit dem Spiel soweit. Ich glaube, das war dein Verdict. I'm okay. I think I'm a bit too tired and slow today and doing all sorts of stupid things, but ultimately I think we got where we need to go. Yeah, Prince of Persia is halbwegs okay. Glad to hear it, glad to hear it. Didn't you also think about playing something else still today? Or do I misremember that? I mean, if you were just like, nope, Prince of Persia is too cool, I'm gonna keep going, then that's even better. Not today, no. Just focusing on Prince of Persia. Okay. Then I just didn't quite focus enough to comprehend, and just my brain put pieces together wrong. But yeah, cool. We arrived at day 20 indeed. Like, we haven't solved everything. I had to skip 2 half days so far. I think I have a reasonable approach for one of the skip days. I just was a bit lazy and was like, okay, I have at least a reasonable idea on how to solve this, but and yeah, that was satisfying enough for me at that moment, and then I was like ready to move on for now. So we skipped day 12 part 2 and day 18 part 2 so far, I think. Everything else we've solved. And yeah, I can quickly explain what we have here in this example. So we have an input such as this. We have always a broadcaster and then a bunch of nodes that have destinations and also have a certain type, like either this % type or this ampersand type, and they behave differently. So basically we start at the broadcaster, technically we start at the button that we push, and then the broadcaster broadcasts our button push. And well, we have pulses. So whenever a pulse reaches a node, something happens with that pulse. The broadcaster just distributes whatever it receives, but it will always just receive a low pulse, so there's low and high pulses. So it will just distribute a low pulse to A, B, and C. So here then a low pulse reaches first node A. And node A is a percent node, which is more specifically a flip-flop. And yeah, the flip-flop is either on or off. They are initially off, and if it receives a high pulse, then nothing happens. But if it receives a low pulse, it flips between on and off. And if it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Conjunction does something different. It has a certain amount of input nodes. So we have here one that is like the inverter that has inputs from, well, only C actually, which is why it is an inverter. And yeah, this one is an inverter because they initially default to remembering a low pulse, but then when a pulse is received, the conjunction module first updates its memory for that input, so it remembers, okay, I received a high pulse or a low pulse or whatever from input X, and then it will send a low pulse if it remembers high pulses for all inputs, otherwise it will send a high pulse. If it has only one input, then it's, yeah, just an inverter. And that's pretty much it. So we have such a network setup, and we have to press a button to send a pulse into the network and see what happens. And once everything is resolved, we have to press the button again. And we have to do that 1,000 times and see how many high and low pulses we send and multiply it, because why not? And then we get our puzzle solution. And I think we're pretty much there. The only thing we have to do is, like, we resolved pressing the button one time. Now we just have to implement pressing the button 1,000 times, but that should not be that difficult, I think. You're welcome, you're welcome. That's the least I can do. This will be confusing and annoying enough. Even with that. Did I say thank you for the follow, by the way? Thank you so much for the follow, Tiki Peak. I'm sorry. Brain is slow and easily distracted. But I did notice the follow, and I very much appreciate the follow. Thank you, thank you. I forgot in which order we write the things in the for loop. Is it like this? I hope so. Okay, so now we run this while loop 1,000 times, but if we want to run it 1,000 times, then this doesn't have to be on there yet. Otherwise we would just have to rerun it 999 times. So first we push onto the node stack. The name should be broadcaster. The pulse should be false, and the source should be null. I think that is it. So yeah, what we do here now is we 1,000 times push the broadcaster onto the stack and then work with the broadcaster as the starting source pretty much. So this is pressing the button 1,000 times. And then we let this while loop run. That basically we have this node stack, and on our node stack are just the nodes that currently get activated. At the start it's the broadcaster, then the targets of the broadcaster, and so on. And yeah, the one other important thing is also the order of operations. So things are always done in order. So if the broadcaster activates node A, B, and C, then we resolve node A, then node B, then node C, and we don't go depth first, so we don't go node A and then see the follow-ups of node A and then the follow-ups of those, but we go, yeah, that's why I do pushing and shifting, so that we always push the new stuff to the end of the array and pick the current stuff from the start of the array. And then we just let our activate node function run, which is this abomination here. It is actually not that bad, but I started off in a completely wrong way. And, well, now it should work though. Let's see if this works. I think this code seems fine. It's actually smaller or equal than 1,000, that we really press it 1,000 times, from 1 to 1,000. And, well, we keep track of how many times we press the things. So, let's see. 4,000 and 8,000. That seems correct. Then we multiply the two, and then we get the correct result, for now. 1,000 times there is 999 numbers that are... I fixed it already, yeah. Let's do it. Yeah, that worked. So my implementation of the 1,000 button presses, which are unnecessary, and they're gonna break our neck in the next part, I'm sure, but for now it's good enough. Because it just repeats 1,000 times, so letting this whole network flooding thing run 1,000 times is kind of stupid, but we can do it stupid for now. And then later on figure out where the return to default state happens and then just multiply from there. But for now this is good enough. Let's go with the slightly more complex one. They have another example in here, so we're gonna try that. I think that's this one. Yeah, that's this one. So let's just throw that into the input data. See what happens. It breaks. Why? Oh, I think... No, wait, that doesn't make sense. Why does our node have no type? Our nodes should always have types. Actually, yeah. No, wait. So what we push here is just the name, the pulse, and the source, right? That's normal, like as an object, of course. Find the element. I'm still confused. I have to think. Everyone, I didn't even say it. If you're not following Legume, please follow Legume. Legume is super awesome. Really comfy, cozy, good vibe streams, and highly recommend. Do it now. I wonder where things go wrong and why. Push type B, we push type this. This is on our node data. Hmm. I'm so confused. Why does it not work? When does it break, by the way? I mean, we can find that out, right? Okay. During the first run already, so something is just breaking us instantly. At the input data, specifically output, yeah, I was wondering that something must be different, and yeah, the output has no... is no... okay, let me think. What are we doing? I really have to think about how we're even parsing this input data to begin with, which is kind of the problem. That I forgot everything already, which is what I said. Brain very tired in a way today. Of course. Yeah. We're putting the destination onto our stack, right? But it shouldn't go onto our stack. Like our stack of things to do something with, and we don't find output in our data then. So yeah, okay. We have to consider that. That's a problem though for the actual puzzle data. So we have to kind of create a list of things that are destinations but not sources at the start, right? So just like we have this conjunction data, we kind of need a useless destination data or something like that. Okay, how do sets work in JavaScript? Set add then the thing. Okay. Okay, so... Okay, here we track the destinations. Just gonna... should be add, right? Like this. Seems good. Okay. But actually, can we just... Node 1 should always be the thing, right? So we can just... Whoops. Can just put this here at the start regardless of the if statement. Okay. Just start with that. We still have to remove stuff from this all destinations thing. What is going on? Ah, okay. My bad. Okay. All destinations, we have them here. Great. And now we want to remove stuff from the set. The things that do function as sources. So when and how do we do that? I mean, we can also do it on the fly, right? Like basically, no, but we can't. We can do it on the second go, like second run through our data, which is what we're doing here, right? Like now we have them as nodes in the node data. So nice, now our set only has output in it. That's exactly what we need. Wonderful. Okay, and now we need to say if the thing that we currently have as a destination is part of our all destinations thing that we probably should rename. Lost destinations. Dead ends, also a possibility, but whatever, it's lost destinations now. That's much more cryptic, and I like cryptic. So, lost destinations. So before we push something to our node stack, we want to check that it's not part of our lost destinations thing. We still want to send the pulse. Okay, so that if has to be here. And only here. Okay. I mean, not only there, it has to be in many more locations, but it has to not have this inside. Okay, if not... lost destinations dot has. It's probably has, right? Okay, yes it is. It is exactly that. Perfect. Hi Plompy. Plompy, Plompy, Plompy. Plompy. I agree, so cozy that I don't even need to understand the language to feel welcome. Aww, that's nice. And true. But Legume also switches to English pretty frequently. Like, whenever English-speaking visitors make themselves known and heard and seen, then Legume does add a lot of English as well. So that everyone is taken care of as much as possible. Okay, so if it doesn't have, basically, like we negate, we do this pushing, and only then. That's good. So we add that pretty much everywhere, and then we should be good. Wherever we interact with the node stack anyway. So it should be 2 more locations. Pompey is licking my hand. Very helpful. But yes, I would also hang out on Legume's stream even if I didn't understand a word. So Legume, stream in any language you like. I'll be there. Actually, that would be cool. Like, if you were to stream in languages I don't understand. Okay, that kind of worked out, but I have a feeling that something is wrong there. I don't think it's 4,250 for both, right? I'll check something. It went through anyway. I'm still confused why I would not get the right result here. Maybe it is the right result. I don't know. We'll see. No, you're cute. Yeah, it's 4,250 low pulses, but only 2,750 high pulses. Why did I not get that but 4,250 twice? That is weird, right? Let's see if the original thing still works. Yep, that still works okay. Hi /live, moin moin, good luck finishing the AOC. I'm not even sure whether I finished day 1 this year, simply can't find the time. That's fair, that's fair. I'm on day 20 now, but finishing will still take a while if I continue at this speed, because I'm still on part 1 here, and I've spent 3 hours on it. But it's okay, we can take our time. I'm just confused about whatever's going wrong here. It's working great for part 1, but it's not working great for part 2. For the other input, I mean. Why do I keep tracking a set of nothing here? Ah, of course I keep tracking a set of nothing here, because for this input there is a set of nothing. Okay. Something is very weird here. Don't understand. That's so stupid if the simple example gives you a good answer and the other one doesn't. But maybe I shouldn't go with the 1000 button pushes for now, but see how it goes for 1 or 2 and see what happens then. Because somewhere it must be going wrong. So yeah, let's change things accordingly. Okay. Not 1000, but just 1. 6 and 4. Is that true? That was the first one, yeah. Okay, we got lyrics now. That's slightly distracting, but okay. Probably outro track. We played through Chrono Cross. I think I know one thing that I... No, probably not. It should be fine. Well, let's count. 1, 2, 3, 4. 1, 2, 3, 4. So apparently we should just end on 4 here for the first button press. Right? Like if this is all that happens, a low to the broadcaster, a low to A, then a high to the inverter, a high to the con, a low to the B, high to the output, high to the con, low to the output. Yep, that looks like that is what should happen. So why do I get 6? Well, let's console log more useful stuff, maybe. Oh no, I'm actually... Wait, no, this doesn't make any sense. But it does make sense, kinda. Because that's what I thought, but I thought And I thought I didn't do it, but yes, I'm not counting this here correctly. That's the problem, because I'm counting it already while generating, but I only generate once, right? Or is that the case? I think it's the case. Maybe it's not the case. No, here it is. Yeah, okay. There we go. That's fine. Okay. So what I thought is actually... What I first thought is wrong, what I second thought is correct. So... Okay. Can just console log our node stack after every run. That's the simplest thing, right? And maybe also 4. If you're going to spend 3 hours on part 1, good luck with part 2. Yeah, I know. Okay. We start with A as a destination. I would say that makes sense. Yes. Okay. We should also maybe not only keep track of the node stack, but also of our current count. High pulses, low pulses. Why do we have 0,2 here already? Oh wait, we do have 0,2. That makes sense. A low pulse gets to A receives a low pulse, A switches to on and sends a high pulse to inf and con. And now the music has actually stopped. So where do we go next? Chrono trigger. Chrono Trigger complete soundtrack on piano sounds nice, but that might again be problematic copyright-wise. Any game soundtrack recommendations, anyone? Or anything else that might not give me a copyright strike. Can go for Cult of the Lamb again, because why not? Yeah, that's nice. Okay, we were trying to follow through on this here. So far it makes sense. We start with 0,2. Basically, we start with 0,1, but then we send another pulse. Like, we send a pulse to the broadcaster, and from the broadcaster to A. So that makes sense. Then, from A, we send 2 high pulses to the inverter and the con. Then something What is... The con sends to output. Okay, that's also fine. So something gets +1. Then we have the B. And for some reason, the B adds 2 here, which doesn't make any sense. Why is my B adding 2? That is what is happening, right? So yeah, like this is afterwards. So after we process the A, we have 2 on here. Do we, or is it before? No, it's before, right? Because yeah, we have the button pressed from the source to the broadcaster and from the broadcaster to A. So before A does anything, we're on this. So this is before. Okay. So after A, we have 2, 2. Makes sense. After the inverter. After the inverter, we have 2, 3. Also makes sense. After the con, we have 4, 3. That doesn't make any sense. The con sends to output. Oh, because output has no type. Gosh. God damn it. So that makes things weird, apparently. For some reason, output not having any type leads to problems. Why though? Shouldn't it just be... It should be based on the number of destinations. I don't see... Don't see how that would cause issues now. Okay, let's follow further. So yeah, after the con, somehow we go from 2, 3 to 4, 3, which I don't understand. Sense. We have the B goes again to the con, and then yeah, again after processing the con, now we add 1 here and 1 here. Again we add 2, which doesn't make sense from the con. For some reason we add 2 there, which I don't understand. So let me see what our logic again is. So our con is in here, exactly. Yes. So... Oh. I think I see the problem. Yes, I see the problem. God damn it, what am I doing? That is so ridiculous. Why did I not close my for loop where it was supposed to be closed? Ah. There. Okay, well, that's better. Okay. Now let's run it 1,000 times. Ah. Yeah, that takes a bit longer, but we get the correct result. Easy peasy. Well, if we don't console log as much, it will go quicker. So. Wait, I didn't save. Still didn't save. Well, I should maybe console log this. Ah, god damn it. Okay, actual input data now. Let's go. What the heck am I doing today? It's okay. Sometimes we have slow days. Copy this. Let's also do the maths already now. There. Got a result. It's gonna be correct. Trust me. It's not the right answer. My answer is too high. No! Why? Okay. Why though? Yeah, it looks a bit suspiciously high on the low pulses here. I have to double check the test data again to see if that was actually right. It looked right, but... There's still an error at the place you just changed, calculating the steps. Hint. At the place I just changed, calculating the steps? You mean, calculating... You mean around here, or... I don't exactly know what calculating the steps means. Which steps am I calculating? Calculating the pulses count. Okay. I still wanted to check here if this was even correct. That's the first thing. 2750, 4250. I mean, this seems correct at least. So that's kind of nice that that is correct now, but apparently something else is wrong then. What do you mean in the same part of it? Like where I'm managing this one? Or... I mean, for this one, we always get just the low pulses equal to the amount of output thingies plus 1. This seems fine. Here... if it received a low pulse, it also adds to the high pulses, either if that's the one that it switched to, or the low pulses, so that seems fine. And in this one, where I just looked, so down here, so for every state in our node state thingy, we check the state value. Wait, is that... yeah, no, that is fine. That is... I think that's fine. Yeah, I shouldn't have called it state, but whatever. I should have called this states to begin with, and then state dot... yeah, we have a state name. Bug I just fixed is still there, just a bit different. So what I'm doing is, if my node type is this, I find the corresponding node. Just a second. Node state find element name equals node info source. God, what am I doing up here, by the way? Yeah, what am I doing here? No, actually it's fine. So, yeah, for the source one, we're setting it to the pulse type. That makes sense. Then we check if, like, we first set our all true variable to 0. Then we go through all our states. And we just say if state. Well, that's a bit stupid, right? No, it's not. It's not. Because this is... yeah, like... this will be true or false, so it's fine, yeah. I'm gonna change the name, but... one state? Yeah, it knows what is what, so there was no... Good night, CC. Good night. Sleep well. Thanks for hanging out. I just fixed is still there. How? I don't understand. So if my one state is true, so if we have a high state there, we set all true plus 1. And then... oh, for the dest of destinations, we do this, so my if all true is Is it? Yeah, it is. Okay, that's... Okay. Yeah, I see. I do this for the best of destinations, and then I'm adding all the destinations at once, which is... come on. Okay, so... Let me see what I... that I really fixed the stuff this time. Let me comprehend what I'm completely doing here again. I'm going through all our destinations. Well, and if all are true, and my current destination is not a... lost destination, then that's fine. Yeah, so basically we have to just like get these out of there. Do another if all are true check probably, but outside of any loop. Okay, forgot what I copied. Okay. Yeah. I got it now. Sleep well, CC. Thanks for hanging out. Still getting the right result. Yippee. Okay, so maybe we also get the right result for the actual input data now. This is not my day, but it's okay. Not every day can be my day. And if we at least solve part 1, then at least we solve part 1 at the end. Okay, we're getting a more reasonable number for that part. Interesting that it still worked for that sample data and kind of worked for the high pulses at least. Anyway, multiply. I mean, I hope it's actually the correct numbers now. Well, let's see. Certainly lower than before. Yay! That's the right answer! Thanks for the little hint, Nineberry. I really need to maybe write some comments on my code to comprehend better what I'm doing. Maybe. Because instantly after writing my code, I forget what I'm doing, which is not good. It's not very helpful if I need so much time to just like re-comprehend my code. Anyway, what about part 2? That's gonna be trivial now, right? The final machine responsible for moving the sand down to Island has a module attached named RX. The machine turns on when a single low pulse is sent to RX. Reset all modules to their default states, waiting for all pulses to be fully handled after each button press. What is the fewest number of button presses required to deliver a single low pulse to the module named RX? So, don't know if I understand this correct. So we probably have an RX in here already, I assume. Yes. I mean, destination RX anyway. I don't know if this is gonna... I don't know if I'm not comprehending the whole thing, or... I just want to know when RX is first reached, right? I don't know, maybe apparently I'm not comprehending this correctly. Well, first I'm gonna create a part 2 file. I don't quite see where the difficulty lies yet, honestly. But apparently I must be missing something then, because it sounds like it... Run the code and you'll see why I'm so flabbergasted. Okay. Oh, you mean because Rx is never reached in these 1,000 steps that we have taken, probably, right? That's... okay. Yeah, I thought... I kind of assumed there would be looping already in the... No, then I understand what the problem is. So it's not gonna happen in 1,000 steps. It's gonna happen after the 1,000 steps. Okay. Understood. Understood. Then I see the issue, actually. There only one Rx in here, just to simplify things. Yes, only one Rx. So basically, if our node is named NS, then we know we have it. Okay. This is also not a good name anymore. Just the next node. Nah, it's not really, it's the next node info. Something like that. So that's not gonna ever console log that, because otherwise it, yeah, would be probably trivial, right? Yeah, no, here it is in these 1,000 steps. None in 10,000 either. Nope. Nope. Wait, is this really... Oh, I'm running part 1 all the time. Well, I was wondering why it was still going so fast. Well, here we go. Here it is? Wait, what? So, then... Wait, what? So many here it is? That's confusing now. I misspelled the name. Where? You mean the name of the function I'm calling? The name of the thing I'm calling here? That it was part 1 and not part 2? Or do you mean in here? Because I did write NS because NS is the node that calls Rx and sends a pulse to Rx. Oh, but it needs to be a special pulse, right? Does it have to be? Like I checked my input data and like we want to know what triggers RX and NS triggers RX, so that's the thing, right? But it was a special pulse that needs to reach RX, so okay, I understand. That's something so we do reach the node that activates potentially RX many times, but in what state is it then? That's the question. Because the task was a low pulse needs to be sent there, so we don't only need to reach NS, but NS has to be in a state of all inputs are in high mode, right? Is that the thing? I think that was the thing. Why can't I find the thing where it says flip-flop, whatever? Conjunction, there, okay. Yeah, if all are high pulses, it sends a low pulse. That's the thing. So that's the other part that I didn't check for. It doesn't only have to be the NS node, it also has to be in the correct state. So can we check that here as well? We should be able to, right? If we just like... This part is not really important because that's just... Or is it? No, this is important. Okay, yeah. Okay, so we need to do it in here actually. Check in there. Okay, okay, so if we have the all true state matched to the length, like the all true count matched to the length, and our current node is NS, that would mean that it does send the low pulse to our RX1, right? I think that is true. And now we don't have a here it is, obviously. Okay, just that to see if this just works in general. Yeah, now it shows again when we reach it, so it will show the things. Wait. There we go. Now we just run it a few more times and surely we're gonna get there, right? Nah, still no. And this already took noticeably longer. Okay. Okay. You can still go higher. Factor 10 still seems reasonable. But yeah, it's already long. And there must obviously be a better way. But I mean, this is already one step. Like what I'm doing right now specifically is just the same as checking if we ever send a low pulse to the RX. But there is a foundation here to make it a bit more efficient already, potentially, because yeah, what sending a low pulse, my solution has 15 digits, so you're gonna have to wait very long. Okay, yeah, I mean, that's already taking far too long here. I didn't think that factor 10 would cost this much right now, but apparently it does. Yeah, no, so I have like so just this realization that sending a low pulse, I mean, it's an obvious realization, but sending a low pulse to RX just has the prerequisite that the NS, I wish that was, actually we can change the name, right? We could, but actually, can we easily change it? I just don't like that it's called NS. But we can't, I mean, we could easily change it for the whole document, but whatever. I'm gonna just say that it's short for nice stuff. Why is this running so long? It didn't take... Okay, there we go. So, yeah. What I find interesting is how similar these first digits are in every case. That's a bit weird, right? Is there a reason behind that? Probably because it's multiplication. Makes sense, yeah. Yeah, okay. That will be the reason. We're not just counting, we're multiplying. Okay. And I think somehow that makes sense then. But I don't even know. So, okay, just going higher and higher up here is not the solution. It is not the solution. So it is the solution. No, it is very much not the solution. But yeah, so what I was thinking of, solution potential-wise, was to try and figure out if the activation and deactivation of RX's input thingies has some rhythm to it. That's probably interesting, right? So yeah, that's what I'm probably gonna try to figure out. So we're gonna send the X in here as well so that we can track it in there and console log it whenever we get there. So we don't want all true. We just whenever we reach ENS for now, we will just keep track of what the state it's in, probably, and then see what happens, and maybe we can see a rhythm or something. It will be a lot of outputs apparently, because yeah, we have seen that we get to the NS node many times. So we'll see. And apparently it's gonna be not that simple of a rhythm. It just falls all the time. Everything is always false. I mean... Okay, so we're not gonna console log everything, but we're only gonna console log when something gets true, I suppose. Hi, cats. This should be a lot of empty somethings. I just want to know what it exactly it is. No, it doesn't do that. What is it? Why is it? Why is it now giving me all this? I don't want to copy. I want to terminate whatever is going on here. Thank you. Mr. Cat, what are you doing there? Okay. Why do we get DC state faults all the time here now? That makes no sense to me. Wait. That should be it, right? Undefined, okay. There we go. How did this is undefined work? I know there is, or is there something like is undefined? Undefined is certainly falsy, right? So we probably can work with that. are you doing there? Stop sitting on the keyboard. No, no, no. Ah. Oh, we got some yays after a while, apparently. No. So we don't want the yays, we want to know which ones it actually is. So then we, for now, start console logging. Kabi, stop stepping on the mouse. Why are you doing this to me? Why? Cats, stop being rude assholes. Trying to think here. Not even that late yet. It's 5 a.m. Stop pretending like you're starving. Cute little assholes. You two little jerk faces. Okay. Where were we? I wanted to console log some more useful stuff. Which is also gonna be... Oh, X is not defined. Wait a second. Ah, there. Cool. So it actually switches what is and isn't true. Let's see if we can already maybe recognize some kind of pattern. I mean, the main thing is what we really have to monitor is DC, RV, VP, and CQ. I mean, we can go further back and further back and further back, but yeah, those four are the ones that are interesting. And we need to monitor the changes, and I'm not really doing a great job of monitoring just the changes. As soon as something is true, I start monitoring, and when everything is false, I don't monitor, which is kind of meh, but okay. But yeah, the problem is I will not even notice when it becomes false again, because I will just know like that, like as soon as something else gets true, or it gets there while it still is true, or you know. But here between these two something switched, so at some point between these two VP must have been switched off and RB must have been switched on, but I don't even know where that is, so I can't get anything from here because I'm not getting the switching, but just, well, at most the on switching that I kind of get, but not the off switching, which is also important. Because then I get like the... Why is this the same X? This is also the same X. On X is just one button push. Fair enough. Fair enough. Stream okay? Oh, wrong PC to start OBS on. Close. Because something YouTube is complaining. But looks like we're streaming perfectly fine. For some reason YouTube says it's not getting enough video data, which is weird. I mean, we do have some dropped frames, but... Oh, we actually do drop quite a bit of frames right now. Now that I'm looking... Yeah, it doesn't look that great. Well, it's kinda on and off. Dee 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 ba dee ba dee 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 ba dee ba dee 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 ba dee ba dee 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 ba dee ba dee 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 ba dee ba dee 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 ba dee ba deep. Hi, it's Sorchenheimer. Welcome, welcome. I do computer things. Nice. Mostly. Let me see. Welcome in, everyone. Thank you so much for the raid. Okay. I do computer things, mostly 8-bit assembly for the NES on stream. Ooh, that sounds pretty neat. And way above my understanding of things, but that has never stopped me from hanging out on a stream, so instant follow. I want to see that. Welcome, welcome. How are you? How was your stream? What did you do today? Did you do just that? The assembly stuff for the NES? I'm curious, but yeah, thank you so much for coming in. I am tinkering around on day 20 of the AdventOfCode calendar, and I see now what the problem is and why this is somewhat difficult, but I feel like I might have a good approach, somewhat. Like, I mean, I struggle with the basics because I just recently got back into coding and still struggle with just finding the right tools for the job, and my cat is doing stupid stuff. Just a second. Hey, can you not eat random things? Also, I'm stuck. Ah. Hey, no, stop it. Ugh. I mean, yes, this is the cat toy, but I still think he should still think he should not try to eat those stringy things. I mean, they're pretty good attached, but they're just all slobbery and full of saliva now. Anyway, yeah, cats. Gonna wash my hands real quick. It was good. And yeah, we were getting a Famicom drawing tablet working. Ooh, that is intriguing. I don't think that's original hardware, right? That sounds really neat. I just had some frame drop issues a moment ago, but I think it's fine again. Frame rate seems stable. I hope it's all right. But yeah, that sounds really, really cool, and I'm curious. So yeah, I gave you a follow, and I'm curious to see what you're doing. I appreciate the raid. Welcome in, everyone. Yeah, I don't know if everyone is aware of what the AdventOfCode is and what was going on there. But we have a little challenge here, and it is original hardware from 1990. Ooh, okay. Interesting. That's cool. That's really neat. I did not think that the NES would have something like that, but that's cool. But probably then Japan exclusive or something, because all those fancy weird gadgets typically are Japan exclusive. Still haven't finished. Yeah, me neither, as you can see. I am on day 20 right now, day 20 part 2 actually. I struggled for far too long with part 1, mainly because my own lack of coding expertise and just like, yeah. Yeah, Japan gets all the fun toys. They do. They also make them though, so me. Fair is fair. Basically, we have a fun thing here. We have like a network where different nodes do different things, and we send pulses through the network. And right now, this cat is it's a cat. Look what I found. It's a good cat. Most of the time, it's a cat who's slobbering all over toys, and also a cat that can get really cuddly. And also a cat that can be very annoying, but I love him. Ah, annoying little babies. Yeah, anyway, we sent the pulse through the network, and right now we want to know. So this is our puzzle input data, and we have this this Rx node, and we basically want to know when this Rx node is gonna receive a low pulse. But the Rx node is only an output node of the NS node, and the NS node will only send a low pulse to the Rx node if the NS node before has received high pulses on all its inputs. And our task now is to find out in which step that is going to happen for the first time. So in which step is the Rx going to be reached while all its inputs are active, basically. That's the task. And I think it's probably doable if we can figure out some routine that its inputs nodes are going through, like some rhythm. Then we can see what their lowest common denominator, is that the word is? Probably. My cat wants to start an OnlyFans account. Did he show his butt to the world? That might, yeah, maybe he wants to do that. But yeah, so yeah, we're just trying to figure out what the rhythm basically now of these things is, to maybe find a, yeah, I gotta change my code up a bit to figure out when exactly these things happen. So what we want to track now is actually what kind of nodes do we have anyway? We have DC, RV, VP, and CQ. What are they? Makes sense to look for this, because then this is just, okay, this is also one that needs all its inputs activated to send a signal. Okay. Are they all? Probably. Yes, they of course are. Okay, yeah, makes sense. That's why it's taking so long. All right. I mean, fair. So, um, hmm. God damn it. I tried to figure out how to ideally write code that does track this properly. Also, this is also over now. Spiritfarer, why not? Let's go with that. More soundtracks. Yeah, I'm just trying to wrap my head around how I can ideally track these state changes and not just the state themselves itself, because for that I need to track what the state was before, kinda, which is somewhat annoying, but okay. Because actually it's not that big of a deal, right? Because this is just need to establish something like an external thing that keeps track of it, like what the current state was, and then just keep updating it and keep comparing it, and when it changes, then yeah, that should do the trick. So yeah, that makes a lot of sense. I'm gonna call it input tracker because it's the tracker of the inputs. I'm tired. Almost 6 AM here. Don't expect me to make any sense. Okay, that makes sense, I would say. Because now... I still don't know if it's ideal, because it will only show me the update when we reach the RX node, I think. Right? I mean, kinda, but that is... when it's relevant, I assume. Not the RX, the NS, but whatever. I think maybe it's fine. I'll try, whatever. It might make more sense to just check if we reach these nodes and if they send a high. That's better, yeah. Okay, we're gonna do that. And when they do that, or yeah. Okay. Decisions. Oh. Rather than checking for this one, we are gonna go for, yes, it's also an end node, and then let's start by this. Yeah, it makes sense to have this. What is this again? This is if something is true. Okay, we don't need this part. And basically we just want to know if it's all true or all false when we reach one of the nodes. So gonna block that. Not with this one, but with another one, but that's fine. I'm not sure what I'm doing right now. This is moving stuff around. Yes, okay. Why are you... Okay, because I'm moving the... That's better, thank you. Now things make a bit more sense again. Okay. And I'm moving the stuff again. Okay, we don't need this, we just need to know. So this is when it's actually active. So we say active, but we also need the node name. Okay. Now we want these names actually. Yeah. Okay, that doesn't make sense to copy that. We write it like this. I really hope we can write it like this and don't have to write node name equals every time. Obviously, this doesn't have to be here. All right. DC is active a lot. Good to know. DC just stays active. Which is nice. So we should probably see where it changes rather than console logging it all the time. Oh, also it's... Yeah, okay, so this is not working like it should. Okay. I was afraid it might not. We probably could have done this nicer with regx or something, but whatever. Interesting. I can't write it? Oh, I can. That was before. Yeah, okay. So why is it instantly active? I don't understand. That doesn't make sense to me. I'm an idiot, of course. This has to be checked as... Wait, no. What? I'm very confused here. Okay, so... I think I understand, but I also hate it. Yeah, I understand. Not like just active or inactive, but it's changing, of course, multiple times throughout the cycle and... Yeah, okay, that's hell. I thought I had something, but I don't quite. So in the end, we do just want to lock this when we are on our... I mean, that's the only thing I can imagine, like when we... Yeah, when we reach our NS node, we want to check if something changed about this node layout. I think that's what we want to do after all. Okay, well, let's try that again then. So my idea here was wrong. It's not about... No, Mr. Cat. Don't lie down on the keyboard, please. we don't want that. We don't want that. No. No, no, no. Okay. Cat on my lap. On my lap, it's fine. Not on the keyboard. So all of this is pointless. Thank you. So this goes out here again. And it's stuck up there. I'm sorry. I'm gonna fix it after the stream. So here we are again, but we want to check more. We will create this thing that I wanted to create at the start. Apparently. Input tracker. No. Well, this should Wait, what's wrong? Problems, expression expected, where? Okay, there. Not right now. There. This is what I wanted. To stringify so that we actually compare the contents, right? That's one thing I remember at least.
Oh, this is space. I'm in space.
All right. Does that mean you're going to space? You're going to bed? Or that's at least Korenchkin's message when Korenchkin is going to bed. JSON stringify the tracker thing, which is not really tracking anything yet, but let's just roll with it. Yeah, there we go. Only tracking when it's not equal to everything false again, which is nice. Or console logging, I mean. But now we actually want to see if it changes, so we need to update our input tracker. So, not only console logging, but also... Does this work good enough? I hope it does. Of the node dot state. Okay. Nice. I think we're getting just that. We're still getting a lot. What if we just go for the first one for now and try to find a pattern there. That's a start, right? Might get a pattern, I don't know. Let's just see which numbers we have. We start at 3797, and then we multiply that by 2. Then we get that another time. And then we get that another time. I think that's our pattern. Let's just assume that that is our pattern. I'm gonna put it in my notes. 3797. I'm gonna do this by hand. 3797. Now we do it for the 1. I think we might be onto something here. Okay. 4051. It's our next one. And... Wait, did I go? No, it's not the same one. Halfway there, kinda. At least as far as collecting our data go, and then we just need to find the lowest or smallest common multiple thingy, you know, the thing. 3847. And the last one.
Infinity years in the serious room.
Hey, Shrugs hasn't solved this at all, so... And yes, I was just thinking I could have put a variable in there and just changed that, but no. We're gonna change it 3 times. 4 times. No, change it 3 times. I was right the first time. And... we got a 3877. And now... there. And because I don't want to do maths, I'll let the internet do it for me. I don't even want to write code to do maths for me. Someone else has done it. I'm just gonna put my numbers in there and be happy. Bam. There we go. Solved it. I think. I assume. I hope. Yes! All right, we did it. And, well, first part took me much longer than the second part, because I'm just bad at coding. But I'm getting better. At least I'm having the right ideas and understand the algorithms. Writing them, different story, but we'll get there. The brain is there. Just need to practice things. Ah, this is satisfying. I'm glad. I'm glad. I'm officially a genius now, or you are officially stupid? Why? I don't think either, but it's just... I mean, that seems to be a common thing with these. Ah, okay, yeah, I'm not gonna say anything. Not gonna say anything then. I won't spoil the approach. Yeah, okay. But I'm gonna say, I don't think you're stupid and I don't think I'm a genius. It's just like, you gotta have the right idea. And yeah. Thank you. Thanks for the confetti. Thanks for the well done. I appreciate it. And still thanks for the kudos, Shrugs. I appreciate it. Yeah. I think I also was a bit lucky in how I looked at the problem from the get-go. That helped. So yeah. Let's see, what's day 21 about? We earned this. You managed to catch the airship right as it's dropping someone else off on their all-expenses-paid trip to Desert Island. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again. Great work. Now we just need to wait until we have enough sand to filter the water for Snow Island, and we'll have snow again in no time. While you wait, one of the elves that works with the gardener heard how good you are at solving problems. Aww. And would like your help. He needs to get his steps in for the day, and so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. He gives you an up-to-date map, your puzzle input, of his starting position S, garden plots dot, and rocks pound sign. For example, these. Okay. Accessible spots, we have rocky spots, and we have our current position. The elf starts at the starting position, that is, yeah, I would have assumed, which also counts as a garden plot, that also I would have assumed. Then he can take one step north, south, east or west, but only on 2 tiles that are garden plots. Yes, just that I would have assumed. This would allow him to reach any of the tiles marked O. Yeah, that is the 1-step scenario. He then takes a second step, since at this point he could be at either tile marked O. His second step would allow him to reach any garden plot that is 1 step north, south, southeast or west of any tile that he could have reached after the first step. Yes. Yes, yes, yes. After 2 steps he could be at any of the tiles marked O above, including the starting position. Either by going north and south, and yeah. A single third step leads to even more possibilities. He will then continue like this until, yeah, okay. In this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of the 16. Can't read like this. Standing in front of the screen, Mr. Cat. Hello? Thank you. However, the elf actually needs to get 64 steps today, and the map he sent you is much larger than the example map. Starting from the garden plot, Mr. Cat, what is going on here? No. No lying down on my stuff, please. Yeah. It's many more steps and much larger map. What could we reach? Okay. We're gonna figure it out. Did you win? I did win. I solved part 2 much faster than I did solve part 1, which is easy to explain if one understands that I'm just still kinda inexperienced at coding and struggle a lot manifesting the things that I want to do. Like, I can verbalize what I want to do, but putting it into code, it's still a struggle, but we're getting there, and we solved. The idea was there pretty quickly for part 2, after I understood what the issue was, and we solved. And now we are ready to go into day 21 next time. I mean, I read it already. I wonder if it's... I mean, it might be as simple as that still, to just... yeah, go to every possible current location and just update the map with possible current locations, etc, etc, etc. For the sample input anyway. I somehow have a feeling that this map is pretty big. No, that's not a feeling, that's something I can see. But that we're gonna reach some state of... let me show you what I mean. I mean, the rocks are gonna definitely influence it somehow, but my general assumption still for now is that we're gonna eventually... I don't know, it's 64 steps, so I don't know, but I don't know if we'll reach that state then. 64 steps is not that much, but at the same time, it's exponentially growing, and to the power of 64 is a lot. So, anyway, I was wondering if at some point our map would just be filled with, well, not with pound signs, but with stuff like this, basically. Stuff like this, and pretty much what would happen in each step would just be that it would invert itself. So basically go from this to this and, well, second line. So basically just like invert where we are and where we could be, and of course there will also be rocks, but I don't know how much they will influence. Anyway, this might be semi-stable state. Definitely would make sense to check if we ever reach a state that we have been in before, because as soon as that happens, we know that we don't need to really worry about any more steps, right? Because it's gonna act the same at that point. So yeah, that's definitely a good note. There. I hope I'm gonna read my notes next time. Well, this shall suffice for today. Before I call it, I'm still gonna push this to my repository. There. Ta-da! There we go. Whew. What about you, Joe? Did you win as well? Let's see who is live and who we shall read. Tired. Okay. Who did that? Explain yourself. Ah, Nineberry. Thank you for hanging out. Thanks for the get good. You guess? Alright. What were you up to if you want to share? Also, oh yeah, I was browsing through who was live right now, and that's also why I couldn't see that who I was made fun of by. Kinda would like to raid a Roop, but at the same time, that's too much meat on that stream. Watching cooking videos on break time, ad time, but I really don't want to see that much meat right now. Might have found someone. But I have to sit through the ad break first. Okay, but I can street stuff here. Bad timey feeling, but we'll probably do some Minecraft building. Tomorrow Saturday, it's true. Well, I was just hanging around with family. That sounds nice. Just testing all the animations. Yeah, you're welcome to. Redeem them all, that's what they're there for. Also, always feel free to honk at me or to boop someone in chat. You can put a name after that and do all the funny stuff. I should put more redeems at some point. More sound thingies, I mean. That's what it's there for. So
It's easy to answer.
not safer, or safer actually, but channel name is not safer, is playing Talos and reading the terminals, which I am very much a fan of. So let's raid safer. I've not been hanging out there for quite some time, but from what I remember, it's always been chill there, so I don't really know why I've not been hanging out there. So let's raid over there and watch some Talos. It's still my favorite 3D puzzle game, so it's gonna be a good time. And of course the stream is apparently struggling now. Is it struggling? Looks like it's... No, it's not. It should be fine. It's just lagging for me. That's okay. Yeah, I've started the raid. Thank you all so much for hanging out. Thanks Nineberry for for I don't know, not completely losing your mind over my lack of coding abilities, something, you know what I mean. I appreciate you being here and giving me small nudges when I'm just like stuck for stupid reasons. I do appreciate that, and just you spending time here and yeah, helping me out with the code. Thanks for being here, Shrugs. Thanks for being here, Joe. Thanks for the raid again to Zorchenheimer, to Legume, and I think that were the raids. Yes, and yeah, thanks to everyone who was here, who was hanging out, and who was spending some time here, who might be lurking right now. I appreciate all of you, and might be streaming again tomorrow, but not sure. If not tomorrow, then probably on Sunday. So yeah, that's that. Time to feed the cats, and maybe myself get some sleep. Bye-bye.